Hello everyone, welcome back to the channel. The repository that I will show you in this video will deploy this chat interface with a FastAPI backend, a Microsoft Foundry agent. We have document retrieval with citations, as you can see in this example, and optionally we can have monitoring and evaluation of the agent. This repository was published by Microsoft, so you can use it to learn more about Microsoft Foundry and Azure infrastructure in general. And it is easy to deploy because we will use Azure Developer CLI, which will deploy everything in one shot. The infrastructure using Bicep, and we'll deploy the code also. So let's get into it. Before I show you the infrastructure, the repository is called Getting Started with Agents using Microsoft Foundry. You can find it in the Azure Samples official repository. The solution overview for this project is a web-based chat application with an AI agent running, and it uses the Foundry agent service to deploy the agent. Also, it has Azure AI Search for knowledge retrieval from uploaded files. So the solution architect looks like this. The application code, both front-end and back-end, are running in the same container application. We don't have different deployments, and we have the option to enable application insights and log analytics. The prompt agent, remember my last video, the difference between prompt agent and hosted agents, if you don't know, go and watch it, will be deployed into the Foundry agent service. We will have the option to search for those files using Azure AI Search, which will index those files from a Azure Blob Storage that we have. So we will have PDF and Markdown files. It's worth mentioning that the front-end and the backend are running in the same container app, not in different deployments. As I mentioned at the beginning, this repository uses Azure Developer CLI. With this command, you will have the whole infrastructure deployed. I already did it, so I'm going to show you what it deploys. You can run this one in GitHub code spaces of the container. I did it in my local. You have to install Azure Developer. You have to install Python. It will install automatically Bicep for you. This resources came from the Bicep template when we run the ACD app. It has the container apps and container environment that hosts our application code, Foundry that hosts the agent, and also the model deployment that powers the agent. And the remaining resources provide identity, storage, retrieval, and observability. This container app is the one that hosts our code. It exposes an application URL where we can interact with the application. And you can see the new chat. You can see all the conversations that we have had. You can also query additional routes. There is a route for the /agent where you can see some metadata about the agent deployed in Microsoft Foundry. There is another one for /chat. That is the one that is used by the UI when it needs to send data back to the agent. In addition to that, we can also see the containers that were deployed into this container application. You see how much memory and CPU we assign to this container and the image deployed into this resource. Remember that we are using the same container app to deploy both the API and the front end. One important thing is the help routes, because this FastAPI service is running in this port. So that's why we did this setup. And finally, we have also environment variables defined that I am not going to show you because it has some secrets. An agent is not just a model. It's a collection of models, instructions, and tools. Foundry gives you that. In the section here in agents, you can see the agent template assistant. It is a prompt agent and it's powered by GPT-5 Mini. As I mentioned, we have a tool called AI Search, which basically has an index with all those documents stored in the Blob Storage. The deployments that we did for this project was the GPT-5 Mini, which is the brain of our agent, and the text embedding 3 small. This is for the AI Search to create the embeddings. Let's take a quick look at the repository structure, and I am not going to open every file listed here. I will focus on the files that explain how the application actually works. I'm going to give you the general view, the high-level infrastructure that this application is using. Let's start at the root with this Azure.YAML, which is used by Azure Developer CLI. It defines a single service called API and frontend, endpoints ACD. I'm going to call it from now Azure Developer CLI ACD, and it points ACD to this folder. Also, this deployment is targeted to be in a container application. And finally, we allow a remote container build. Moving into the infrastructure folder, we define the Bicep. This Bicep coordinates the deployments of the Foundry project, of the model deployments that are listed under this core modules. In this part, you will find the Azure Container Registry, You will find also the storage account, monitoring resources, manage identities, and optionally the Azure AI Search. So everything is coordinated from this main.bicep, and you can find the definition of the modules under each of these folders. For the host, you can see here the container apps and so on. Most of the application is inside this SRC folder. And let's start with the Docker file. The Docker file packages the front-end and backend application into the same image. Remember, we are using the same deployment for both backend and front-end, not different deployments. During the build of the image, it installs the Python dependencies from this requirement txt, install Node.js and pnpm, and also build the React application. Finally, it configures Unicorn as the container's startup process and exposes this port. The frontend folder contains the React and TypeScript application, and the most useful file to follow is agent preview, because in this one we load the previous messages, and also this is where we send the prompts to this /chat, and later we handle the messages and the streamed response. The API folder contains the FastAPI backend, and the main.py creates the application, connects to the Foundry project, and if you have enabled tracing, it will enable the Azure Monitor resource here. And finally, it loads the routes in this place. Now that we are talking about routes, in the routes.py contains the important HTTP endpoints such as the route where we serve the chat. We also have chat history, which retrieves the current Foundry conversation. We have /agent that returns basic agent information or metadata. And finally, the /chat, which sends a message to the agent and streams the answer back to React. Another file I think is important to mention is this unicorn.conf.py, because this is more than a server configuration in this project. And the reason for that is because this one, it checks for an existing Foundry agent, and if not, then it will create a new one. Also, if you check in this first method, it will attach files to either file search in Foundry or to AI Search. And there is another for evaluation that we will not touch in this video. The files folder contains the sample Markdown and PDF documents used as the agent's knowledge base. We can ask questions about these products that we define in this knowledge base. With the default configuration, all these files are uploaded to a Foundry vector as a file search, or if we enable AI Search, it will be indexed by Azure AI Search. So the places to remember are the Azure YAML for deployment configuration, the infrastructure for Azure resources, the Docker file for packaging the front-end and back-end application, and the Unicorn configuration for agent initialization, and also I think routes.py plus the front-end for the chat request flow. Now that we have a good understanding of this application, let's follow this message from the browser to Foundry and then back. For that, I have this prompt to show me all the products we manage, and I am using the developer console to see the request. So once we hit send, the first request that we will see is the /chat. This will send the prompt to the agent, and it will use a content type application /JSON. This is the code that's what we just saw. React on send sends that prompt to the /chat HTTP endpoint defined by FastAPI, and it also includes cookies so the backend can identify the current Foundry conversation. This is the route that we were talking about, /chat. And what is important in this one, it's this conversation we will retrieve based on the cookie that the browser sent, or it will create a new one if it does not exist. This will give us the history of the conversation. In this section, FastAPI asks Foundry to execute the store agent using the current conversation and the streaming enable. The method is called getResult, and it's listed here. We can see the invocation that we do to the OpenAI client, and it will enable a streaming so that we don't have to wait for the complete response from the agent. In this part, Foundry streams response events to FastAPI, and FastAPI will convert each text delta into what is called server send event, and immediately it will be sent back to the browser. That is why we put the content type as event stream. Back into the UI, we can preview the responses that we got from FastAPI, and as you can see, we don't see only one response. We see a set of responses, events that were sent from FastAPI. So just to recap, what we did is React sent one JSON request to FastAPI, and then Foundry produced the agent response, which FastAPI translated into server sent events, and then React rendered each of these events as they arrive. The last part that I want to cover is the retrieval of these products. How does the agent know that those are my products? And even how it is able to do these citations. In other words, how does it know that this product is defined in this file? For that, this project has two options, the default and an optional one. The default uses Foundry file search, which basically at a startup, all those files that we saw in the files folder are uploaded to a vector store, and then there is a tool called file search tool in Foundry that is attached to the agent. And the optional part, which is using Azure AI Search, where the documents go to the Blob Storage, and then there is an indexer that processes the markdown and PDFs and creates the index. Then the agent received an Azure AI Search tool that it can use. So let's see how that last part works, because that's the one that I did. The retrieval process begins with the files in the repository's files folder. When the application initializes, it uploads all those files into a container called documents for this storage account. Once it is there, Azure AI Search connects to that using the data source Azure Blob, and then two interesting things happens. We define indexers. An indexer, think about it like a pipeline, and we have one for the Markdown files and another for formats such as PDF or Word. During the indexing, that means when these indexes are executed, a skillset splits each document into smaller chunks and generates an embedding for every chunk. An embedding is like a vector of numbers. The resultant index listed here contains the chunk text, contains its title, contains the reference to the original content, and the embedding vector. And how does the indexer generate the embeddings? Remember the model that I showed you at the beginning in Foundry called embeddings? Well, it uses that model to generate that vector. Now, the final result is that when a user asks questions about a product, the agent searches the index, receives the relevant document chunks, and uses them to generate a granular response with citations like this one. Retrieval has two distinct stages. Indexing prepares our documents ahead of time, and querying retrieves relevant chunks when the user asks a question. If you find this walkthrough useful, please let me know in the comments which part do you like to see next, maybe modifying the agent or exploring in depth Azure AI Search. Thanks for watching and subscribe for more content like this. Bye bye.